All right, so this is week 11 biology. Obviously, I'm Mr. Hayden. We're going to go over a few things that we need to go over just for the next, it's going to happen in the next few weeks. So, example, the first thing to talk about next week is spring break. Okay, so obviously you're off of school, but our school is a little different when it comes to other schools, is that all the stuff is there, all the stuff is open. So if you're behind or if you have zeros, I'm just really trying to catch up, and I get those emails from me that you're going to get caught up and caught up and caught up. This is your time. After this week, I don't feel bad for you anymore. At all. Like, if you're behind, I really, honestly, care less. Unless you're trying. Because it shows you're not trying. Like, I assume say, hey, I'm really trying, I really want to get caught up. And then I check, and they, spend, 10 minutes in a class instead of an hour like they're supposed to. It's like, you know what? You're not really doing what you're doing. So your grade, your grade. I will grade if you do, but I'm not going to go, I'm going to go, a little backwards to make sure that you pass. I'm going to make sure that you're held responsible for what you do. So again, next week we're off, but it's open. So you do need to, if you've already caught up and you're an A, you take that week off and you relax, and I don't want you to look even one thing about it. I don't want you to look at it. But if you have an F or a D and you have better aspirations, if you want to pass, you should be working next week. I can't tell you to work, but I won't feel bad for you if you don't. If I come back and I look to see who works. When I come back, sometimes I get to use the boxes of my baskets are full of stuff after it takes the whole day just to grade everything. I love that. And if I start looking at the names, because I can separate by name, I look for those names that I've been calling through the whole semester. If I don't see your name on there, I basically, any came up from that point on that I get that says I need more help, I need to do this lab, I just ignore it. Or I send back saying you should have done it.
Why should we have a B?
If you're like a B, like I said, if you're happy with your grade, no one should be happy with an F. I mean, obviously, it's like, that's like, you shouldn't be happy with it. It's not like, oh, yes, I got my F. Woo! I'm excited. No. If you have a D, and it's the hardest class you've ever been in, and that's the best you can do realistically, then hey, that's the best you can do. If it's not, expect at least a C, go for the A. Everyone in this room has the ability to get to an A, if you have the drive to get to it. That's the difference. Ability and drive are completely two different things. Some people's ability overshadows their drive. Like when I was a kid, I learned things real quick. That's just what I do. So I got good grades and I didn't try very hard. That's a bad thing that I learned because when I got to college, I had to learn it. You guys are trying to teach it to you now. Hopefully it works. Science notebook. If you just started, your science notebook will start today, or whenever I told you to start. You started at the beginning of the year, you're starting at the beginning of the year. Whatever I told you to start, that's when your science notebook starts. But remember, you need to still go back if you did start late, because the assumption is you learned the stuff at your other school before you came here. If you didn't, you're still responsible for the material, so you have to go through all the various units, and just take notes, and just review them, and things like that. Okay? Because the semester test is cumulative, okay? It's of the whole semester, it's summative of the whole semester. So, I mean, I feel bad for students that are going to, all students show up in April. Yeah, show up in April. And who knows what they learned at their other school. Maybe they didn't do it. Maybe they come here and they're like, I really like this. I'm going to do awesome. But they don't go back and learn the whole semester and stuff. They're going to fail the final and get that problem. I can't do anything about that. I can only teach to what I have. One thing is your grade. Look at your grade. If you don't know how to check your grade, we have a problem. I have people seriously keep up and say, what's my grade? And I'm like, you know your grade every second of every day. Just log in and click on your grade book. There it is. If you're happy with your grade, keep it. If you're not happy with your grade, do something about it. Work harder. If you don't know how to work harder, come to me. That's what I do. I have kids before, literally, I don't know what to do. I want to get this grade, but I don't know how to do that. And I say, okay, you are coming to me, you want to learn, I'm going to show you. Okay, I'm going to show you how to learn. Some people don't know how to learn. They think just reading the material, trying to think of it a whole bunch of times in their head, and then taking a test is learning. It really isn't. It's writing stuff down, reviewing it, looking stuff up you don't know, circling stuff you do know, and saying, oh, I know this, I'm good, I'll have to learn that again. And working on the stuff you don't know. I do that all the time. I still do it. I do it daily. Progress reports went out this week. We had to do it yesterday. Your grade was as of Wednesday morning or something like that. And so for whatever reason, if I give you a B or an F on your thing, and your grade's different now and you're really mad, it's because you did have that room integrated. It just went up from there. Because your guys' grades fluctuate so much. Every week it can drop down and go up a whole other grade because if you didn't do anything in a week, it goes down. So just keep you a reminder that if your parents freak out on you, or your guardians, whatever, that you have an F or a D, show them your grade book and show them what it is now. And just say, I brought it up, it's right there. If you can't do that or you don't know how to do that, bring them in and I'll talk to them. Cool? Cool. About 8 weeks left of school, guys. March, April, May, done. And the beginning of June. That's it. That's all we have left. So you have 8 weeks, and you have to bring up your grade if you do not like your grade. All right. Okay. So let's get into what we're actually doing today. I've got my little pedestal, my little soapbox, and we'll have a conversation. We're going to be talking about oxygen. We're going to talk about the respiratory system. Okay. Obviously, you guys all know that respiratory system. You guys are doing it right now. You guys are breathing. Okay. It's something I like to do. I do it every 3 seconds or so. It's something I do all the time. Everyone's doing it. It's a thing to do. It's really cool. Everyone's doing it. You got to do it. If you don't, you're not cool. So the respiratory system. Now, what is the respiratory system? Help me out here. Give me some parts of it. Tell me about it. Okay, lungs. Makes sense. Good. Oxygen. Really deep into the trachea already. Nice. All right. Trachea. What else? Think of your respiratory system. What is it? What else am I using? Diaphragm is basically right here. It pushes your lung in and out. It allows for that fluctuation or difference in pressure to allow your lungs to open and close. What else? Bronchi. Okay, we're going. Okay, so everyone's like rubbing mouth, and she's like, it's about to allow for the transition of the. No, I like it. We have the macro and micro going on. It's really good. All right, so we're going to talk about it today. Basically, when you look at the, I'm trying to think, when you look at the formula for photosynthesis, by the way, I'm writing it on the board real quick. I'm just going to do this off the cuff. Just give you a heads up. So if you go online, you want to go ahead and Google that if you want to look it up. If we take CO2 and we basically add it to H2O, you add light, it equals to C6H12O6 plus O2. Okay, that's basically the photosynthesis. Okay, everyone's seen that before. Okay, that's when plants make us oxygen and give us food. What we're doing, we're learning about the products from the plant and how we get it back to carbon, or how we get it back to carbon dioxide and oxygen. So they take in one thing and they make whatever they make. We take in food, we take in oxygen, the opposite of what they give off, and we give out water through sweat, through urine, through everything else. And also carbon dioxide is what we breathe out. What you're going to most of that's carbon dioxide. Your body is expelling it, getting rid of it because it doesn't like it. It's not good for your body. We can't survive on that. So that's what we're learning today for this. Okay, so the essential question or concept, what I'd like people, specifically more online to do, people here don't really have this, is where to explain that hopefully in detail, but write it down. You want to be able to explain the cycle of oxygen from outside the air going inside of your body and how it gets to one little cell. And then, how does the cell get rid of, say, carbon dioxide and make its way back out of the human body? So it should actually say, and how carbon dioxide makes its way out of the human body. So I apologize, I should have put that in there. So actually, I'll write that down right there. I'll just put CO2, just make sure. Then how, there you go. Hopefully that helps a little bit. So, and when we start talking about the various macro, which is like the mouth, the nose, the throat, lungs, heart, capillaries, I mean these really big things. We're going to also talk about very specific smaller things, like the little fingers that kind of just kind of are out there picking up oxygen and releasing carbon dioxide in your lungs. We're going to talk about all of that. So you're going to go macro and micro. All right, so what is the respiratory system? The human respiratory system, again, you guys make a difference because there's humans and obviously other organisms, and they have other ways of breathing. Allows one to obtain oxygen and eliminate carbon dioxide. Okay, get oxygen, get rid of carbon dioxide. Breathing consists of two phases, inspiration and expiration. Taking it in, getting rid of it. In means in, ex means out. That's overall. In or endo means to bring in, exo means to get out. Exit, to leave. Entrance, the entrance, enter. I'm just looking at you because everyone's writing down. Right? You're looking at mine, that. All right. And again, if you don't get all this, understand the concept of in and out of breathing and what it's actually named. This is when you start learning shorthand, by the way. When you work on this shorthand. Are you good with me? I would like draw like a Pac-Man now, and like draw an arrow out, and put like if I actually put expiration, then you want to go to inspiration, and I'd just be done with that. That's me though. That was shorthand. All right, let's keep going. Okay, so here's a very macro size or a macro looking. When I say macro, it means like looking at all the big stuff, not actually zooming in on like the microscopic things. You have your nose, you have your mouth, okay, you have your larynx, and basically you have the little flap that stops things from going in your stomach and going in your lungs, depending on what you're doing. Your larynx, pharynx, trachea, bronchia, all these things. And you can definitely, if you want to, you can find a phone line, cut, rip it out, paste it right on your paper to the left, and use that as a visual aid. If you want to sit there and draw that, awesome sauce. Okay, whatever you want to do. Some people do better when they draw. Some people don't do better when they draw. They just need to see it. I'm okay with either way. Big parts though, lung, mouth, throat. Those are the major ones. Okay? Diaphragm. Don't want to disprove the diaphragm. By the way, diaphragm's right here. All right, and again, if you want to, again, you can go back and re-watch this and pause it, at this point, write all this stuff down. But, it tells you exactly what needs to happen. Some people don't realize that the nose and nasal cavity, sorry, my beard's out of the way, warms and moistens themselves. I'm talking back in accent all of a sudden. As you inhale it. And then you can go down to various parts of what it actually does. Each one of those are a structure and it has a function. And you can write that down later on, when you rewatch this, you just need to. Okay, now just focusing up here, you have your sinus, you have your nasal cavity, obviously your external nose, nostril. You can go all the way down the list of the various parts that you have as part of the upper part of your body, from basically your neck up. Notice there's no brain to this. It doesn't say there's no brain. Same. Just keep going. Upper respiratory systems, the tract itself gives a passageway. It gives you smell features. Some people actually don't have smell features. They can't smell. There's that word it's distorted. Some people have that where they smell and they can't smell certain things. And some people don't even know they have a problem. Because how do you know you don't have you don't know. Like you don't know what orange smells like? You guys don't know what orange smells like? Some people when you go into like, I don't know. Well, they don't smell anything. Same with taste to a certain extent. They don't have the sensation of taste. They went away. So they just eat and just taste like nothing. They eat. They eat as a process, not as a pleasure. There are people out there that have that. It's all perception. Yeah, it's all perception. So example like sushi is sushi. Sushi is sushi, right? It's going to taste the same no matter what. It isn't what it is. It doesn't change. It's that. But if you ate sushi, you like a sushi? Okay. I hate sushi. Can't stand it. Even if I put it in soy sauce and flip it around and dip it in like a bowl of it and eat it right after, I still can't stand the taste. I just don't like sushi. Everyone else seems to like it. I don't like it. But for my brain perceives that as, ew, give me steak. And some people, I say, do you like steak? Of course I like steak. You're a normal human being. No, but some people in general don't like steak. So people are vegetarians, whatever. They don't like it. It's all perception. So when you say things like smell and taste, it's how you perceive it. That's why it's not a universal everything that we eat. What's your favorite food? Tofu, okay. I hate tofu. Son loves tofu. My son loves tofu. He actually asked for it. And I give him tofu. I hate it. It's all perception. Why everyone in here will have almost a different answer, but pretty much everyone likes pizza. It seems like everyone likes pizza though. No matter what, that's like the universal, like, yeah. I'll pretend I'm Donatello, Michelangelo, Leonardo, and Michelangelo didn't hear that, okay? That was a Teenage Mutant Ninja Turtle reference for the people who did not know that. You're killing me. All right, looking very specifically at the lungs, you have your larynx at the top, which kind of is a flap that keeps things from going in your lungs. When that gets blocked, it's called choking. And the way to get rid of that is you put your arms around the person, basically you put yourself underneath the diaphragm and you pop up. The idea is that you're creating a pressure in the it's really like squeezing a whoopee cushion. And it shoots air up that and pushes whatever it is out. That's the concept. Sometimes. If it's really locked in there, there's other things you can do. I'm not going to really get into it. I was taught back when I was a professional how to do a tracheotomy. Never had to do that, thank goodness, but we were taught how to do it. When you cut the hole here, and you put like a pen or whatever in there, it's a real thing, but it's like last case scenario. Because someone you can call 911, they can get there and usually get it out quick, and within the time frame of brain still being okay when.
What happens if like food gets into your lungs?
If it gets all the way inside your lungs, you'll die. No, you can get it all the way in your lungs, but then it's bad. It can create like bacterial infections and things like that. But typically your larynx, like you know, if you have a cough, like you get like a juice or something in there, it's like a continuous cough. It's trying to expel it. That's what a cough is. It's expelling stuff in your lungs that's irritating it. That's why when people smoke a lot, they eventually kind of get a cough because all their little fingers in there that we're going to learn about get all like gunk with like tar, and they go, I want to get rid of it. And all these people with vaping and all this stuff, they're going to get the same thing. It's just what it is. It's just cool now. Yeah. My dad actually, because I asked my dad, because my dad's a heavy smoker, and I said, well, have you thought about switching to like a vape, cigarettes, because at least it's more like fluid, it's not like all that other stuff. It's like it's more, I guess, natural or whatever they try to tell you. But water. He's like, so I'm breathing water in my lungs. I'm going to get pneumonia and die. He's old. That's what it is, water in your lungs. He's like, I'm going to get that. I'm going to die from that because I'm keeping it dry. And so he still smokes cigarettes, and this is what he does. And I don't agree with it. I don't smoke. But he does. My mom does. It's what it is. He did that back in the 70s and 80s, back when they grew up. They grew up in the 60s, so let's just say they grew up in the time of that, okay? Let's just be real. All right. Here are the definitions of each. I do recommend knowing what they do, at least shorthand. So, example, larynx maintains the open airway, routes food. So you can just put there, separates food from air, or something like that. You can even draw a little line of a flap, because that's what it does. It literally flaps open and flaps closed continuously. All does. Job. It's just job. Trach supports air to the lungs. The bronchi are the branches, and the bronchi are the branches inside the lungs. The lungs itself are there. And by the way, gas exchange is important because it doesn't just take in oxygen; they also push carbon dioxide into your lungs itself. They do both at the same time.
So then, what happens when somebody gets bronchitis?
Bronchitis, I believe, is an agitation or irritation of the lungs caused by whatever it's caused by. I can't remember exactly what bronchitis is specifically. I think it's an infection. I'm not a medical doctor, but I should be. I should be. I'm spending a whole bunch more money. I know. I agree. But when I was your guys' age, I couldn't figure out how doctors went 20 to 30 hours without sleep at one time before. I can do it now. But before I was like, I don't know how you guys do that. I'm going to not do that. So I didn't give it up. So really is like the main reason I didn't come back. It's kind of funny actually. Think about it. Looking back. Again, we can revisit this later if you guys need to continue to write things down. Okay, so we're going to start going a little bit more into the micro. Okay, we're looking at lungs in general. Now we're going into the micro. You see the exchange between the blood and the alveoli. Alveoli. I don't see. You guys realize like all these different words in every single subject. Alveoli. There you go. All right. But the concept's more important. Basically, you have your blood flow. So as soon as I say blood, we introduce a new system. What system do we introduce? Circulatory. Thank you very much for the people paying attention. Circulatory system. So your circulatory system and your respiratory system literally are connected. They're part of technically the same system because they use the same, they help with it. And then also your nervous system, if you think about it, it tells everything what to do. So you can see how they kind of intertwine with each other. They all kind of work together. So if we look at this, there's a whole bunch of red, which means like it's oxygen-rich artery type blood. And then we have the blue, which is like the vein, which is the non-oxygenated blood. This is like a vein. Don't get into that before we get into this. Veins are unoxygenated blood. Arteries are thicker, and they have oxygenated blood, typically more pressure in there, and that's the ones you don't want to touch. And you can see a push-up of this. You have the blood flow going down. It gets rid of carbon dioxide into your lungs, and then absorbs the oxygen. It does two things at once. It takes it and releases it. That's why it's that continuous movement of air. You need that. If any of those get blocked, you start having issues. People who smoke, they start to get little buildups on those little areas, those little capillaries basically that have the dialysate exchange, and then you don't get as much air in your body. You don't get as much air in your body, so you start to break down. You basically start to suffocate yourself over time, which is what it is. Okay, circulatory and the gas exchange. So there's an interconnection between circulatory and respiratory. Gas, you can't really read it there, but gas exchange is the lungs and the body cells move oxygen into the cells and then from the cells outside of the body. So this is a really, how do you say, really simplified. I mean, it's talking about the heart, going into the lungs, into the cell. I mean, it's very strong. So this is what happens. This is actually very similar to what you have to write for your essential question. Is that you get oxygen coming from the air, goes into your lungs. Those little fingers grab a hold of O2, rip it inside of your body. Your body takes it, puts it into the artery, a main artery. We'll go over that, what exactly which one of those are later. Then it goes inside of your heart. Your heart pumps it to the rest of your body. It will go to wherever part of the body is designated. So, I mean, it's in my finger because as much blood is like my skin right here. It goes in the same place. So it goes there. My skin or my cell goes, thank you very much for that option. I'll go ahead and sign for that, please. Thank you, yes. And they sign for it. And then they say, oh, you know what, here's the carbon dioxide. Take that with you. Cool. It takes it, puts it right into the vein. Veins are unpressurized. Then they make their way back into the heart and push into your lungs. Lung kicks it out. Says, hey, look at oxygen, come with me. Does it again. Just like they better door in the window. Apparently I'm in people's way. So if you guys have questions about that, make sure you ask it. I think this is stuff that you've learned before, I hope. I mean, this is pretty basic type of stuff, but it's still important for you guys to make sure you know it. People who have breathing apparatuses or they have oxygen, because they have it for a reason. One is that there's actually a lot of oxygen in the air, like 79% nitrogen anyways, so it's not that much of air in the actual air that you talk about, like actual O2. So they actually put pure oxygen into they breathe in pure oxygen to allow for what they do take in is more pure, and so they can get more oxygen in their body for a little amount of breathing, so that it keeps them from not suffocating. Why almost everyone that has a breathing problem has oxygen. going. Again, this is just another little breakdown of what happens of it, the CO2 going into and the the CO2 exiting from the cells, and then the O2 coming in and grabbing a hold of it. Just another picture of the exact same thing. So it's just a different view. Here's another kind of more of a microscopic view of the O2 actually making its way through all these various like surfaces and whatnot. Again, you guys don't have to know every single little, like, what is this surface? What is this cell? We don't need to know all. Okay, you just need to know for this class. If it was like AP and stuff, okay, we'll get into it. But we're not doing AP right now. We're doing biology, regular biology. So, any questions about that? Just making sure. Just sometimes it's hard. Oxygen transport, again, same exact thing. Hemoglobin is the actual receptor. It's like a truck that all the oxygen gets into and takes off of, and that transports it. No hemoglobin, no oxygen, no U. Go bye-bye. Again, same exact thing. These are all just various pictures of the exact same thing. But I just leave them up here in case you want to rewatch this and use some of the pictures and whatnot. You can go back and do it. You can stop it and cut and paste it from, like snip tool it. You fall asleep with your eyes open? No. Okay. Because I do it all the time.
I was thinking of that too.
Oh, yeah. Kenny Rogers. Okay. All right. Here, your respiratory system, the cycle again. This talks about more of the diaphragmatic movement. So your diaphragm kind of pushes in and out, and allows for the lungs to be like an accordion, opening and closing, opening and closing, and allows for that breathing to take place. I mean, if you think about it, you breathing, you're not really sucking air in when you go. You're not sucking it in. You're actually removing the pressure off your diaphragm to allow your lungs to expand. And when it expands, air needs to go in to fill the space. And then you push your diaphragm up, expel air, and you're pushing it out. There's really no such thing as suction. It's actually expelling or moving something to allow for stuff to fly in. It's cool if you don't know it. It's whatever. Okay, so lung capacity. Now, you can see right here that various lung capacities can change with various types of issues with your lungs. One of the things I remember when I was a kid, they would just put a breathing thing on me and I wanted to see how well I breathe, basically, because my mom and my dad both smoked and they both smoked in the house, so that's what you did back in the day. And so my breathing isn't actually as normal as a normal person because of that. But, as you'll see in a bit, you can actually, it'll clean itself, actually, as long as there's no permanent damage. But a normal person, that's when you take your little thing and you go, you want to do this? You have this? You go, and you breathe, and it's like, how much air can you push inside of it? What is your capacity? The more capacity, the more air you can take. And the lower the capacity, the worse off you are. Again, here's some of the malfunctions. Here's some of the diseases that kind of go with them. So example, like my brother, when he was younger, had asthma. His asthma subsided just a little bit, but it's basically it's a severe allergy reaction characterized by the constriction of the bronchioles. It's the little thing that grabs the, he gets all agitated. He goes, I don't want to breathe. And it's hard to breathe. That's why you see him go. It's hard for them to take a breath in their mind saying, get oxygen, stupid, like, get it in. And they can't. Like, literally, and that's why they're having trouble breathing. And they take a little medicine, it opens it up, it calms them down, it says, chill, relax, give me a minute, and makes it so they can breathe. And then you can, as you go down this, you can get more and more of the information here. Make sure you know the major ones, which are there. Again, breathing is ventilation in and out of your lungs. There's external, internal. In a second, we're going to look at a couple other animals and how they breathe, because it's different. Well, we're going to learn like a couple of flatworms, or we're going to do like example, like fish breathe air. Even though in water, they still breathe oxygen. It's like weird. You're like, we breathe water. Yeah. They really don't. They breathe air. If you take air out of the water, they die. Okay. What they do is they have these gills. And the gills itself is the same way that exchange takes place, where things reach out and grab the oxygen pulled in. Their gills reach out and grab it, or such. show them there and say, come here, come on, take oxygen, come down. And they go by, that's why they kind of open, push it through, and they go like this. So it's continuous movement. Most fish need to keep moving too. Not all of them, but most fish need to keep moving. Because it's the movement of the air, the water going through their gills that allows for that to take place. Why they die when they're out of water? Because the same way you die when you're in water. There's different functions. Just like there's oxygen in the water. There could be a whole bunch of oxygen in the water. You go, you have it. It's because your lungs don't have the capacity or the ability to reach in and pull out oxygen from water. You just don't have that function. But gills, on the other hand, don't have the function to take them out, and now they don't have the function to be able to take air out of, or oxygen out of the air. They just don't have it either. So that's why we adapt to our environment. We literally adapt to our environment. Some sharks and things like that, there's a six-gilled shark called a chimera that's on the bottom of the ocean, and they have 6 gills, and this allows them to stay stationary for long periods of time. They can move a little bit, and they get enough oxygen that they can hold.
What's this one to stand, stand?
They
And they get like days and then they grab
don't know that one. But they probably have the ability to maintain or hold oxygen in their body for long periods of time. Just like you guys know whales don't breathe with gills, right? Technically they're mammals.
Yeah.
With hair and everything. They go this off and they go. That's a good sound. They go. When they shoot the water out, if there's any water kind of mess around there, it's like they're trachea, they're kind of coughing up and getting rid of the stuff. They breathe in a whole bunch of air. Shut it off, go down. And then we don't realize that as they make their way down, the pressure actually pushes on their lungs and allows it to be more efficient. That's why they can hold their breath longer. So, kind of a cool thing. So another one, insects. Right here, they have their oxygen pulling stuff around their outer part of their exoskeleton. So they're actually breathing through like their skin type of thing. So it's a little different. Every single organism in this world that breathes does it in their own way. They have respiratory system in their own way. Some of them breathe like us. Those are the normal ones, right? Because they're like us. Obviously, we're normal. And then the fish are a different type. Insects are others. There's bacteria. I mean, there's all these different ways people take in oxygen or the material that they need. Again, the fish gills, you can see specifically here. Water going in, going across the various arches and whatnot. You can see they have a blood, the same type of blood system that we have, with the red and the blue at the top picture, taking in the oxygen and releasing carbon dioxide just like we do, and then going into the bloodstream so they can actually stay alive. It's the exact same thing, just a different structure, same exact function. Same structure, different function. Different structure, same function. Yeah, looks different, works the same. There you go. Let's just use that one. Well, I said the wrong thing the first time, and I had to recorrect it. You guys got it? It's the same function, different structure. Looks different, works the same. Looks different, works the same. These figures are okay. Like, make sure I'm confusing myself now. All right, guys. So if there's any questions, make sure you ask them. People on the internet, go ahead. Go to your Dropbox. Go ahead. We can write down some of this thing. Go ahead. And the whole class. I don't say that more than other people say You know, like you just go I don't do that. Good for me. Good for all. So if there's questions, great. Go to your top. Now you're really analyzing. Go to your Dropbox, put in the essential questions, that concept, that movement we talked about. Go and have a good rest of the day. Get that done. Remember, have a good break, and I expect a whole bunch of stuff to be done if you're behind.